Kuwait, who will tell us some interesting stories of remediation of TPH and crude oil contaminated soils.
Hello everyone. At the beginning, I would like to say my pleasure to the Slovakia for the 100 years of the National Day. Congratulations, guys. And today I would like to discuss and to tell you about the new strategy for remediation of oil contaminated soil. Actually, today I'm gonna say, unfortunately, it's a sad story for what happened before 30 years ago. Kuwait environment suffered significant damage resulting from Iraq invasion in 1990. And the result of this destruction, huge quantities of crude oil had released, forming what we know as the oil leak. Kuwait environment today facing a big issue resulting from this environmental hazards. We have around 700 oil wells had been destroyed at that time and created, as we said, the oil lake. We have around 22 million meter cube of contaminated soil. It still exists, okay? And we cannot say anymore crude oil contamination because the age it's increased. It's now become around 30 years. So we can say it's withered oil contamination. Actually, the situation of oil lake right now, or before we explain about the situation of the oil lake, we just discuss about what is the side effect. Once this oil lake exists now, it's going to be a threat to the human, and I think Mr. Carroll, he will talk more deep about the contamination of the groundwater, what's happened when these lakes still exist, and what also regarding what is the side effect for the human being as well. Before 10 years ago, there is interesting study has been concluded that if the oil lake is not treated, it's going to be as a source of PAH, which is the volatile aromatic hydrocarbon. And I know, guys, you know what the PAH means. That's one of the main sources of the cancer. That's one of the oil lake which exists right now. If you see, we have 3 layers. We have the oil sludge, and we have the oil contaminated soil, and we have the normal sand. Regarding for the oil sludge, it's not a big issue. The Kuwaiti government, they decided to make excavation, this will skimming to take it off. But the issue regarding for the oil contaminated soil itself, some of the oil lakes, we have 70 centimeters, and other lakes reach to 7 and 6 meters. And the situation of oil lake right now, it's hard surface layer because as you know, we are in the middle of the desert. So the temperature, you are talking about 60 Celsius. So there is no volatile, no semi-volatile. We are dealing with the heavy oil contamination. Okay. So that's number of oil lake which exists right now. We have around 172 in the north. We have around 69 which is near from the residential area, and we have around 200 oil lake which is in oil sectors. So these lakes, have some side effect because even for the oil production, for the transportation, even for the nearest, because they are near from the residential area, they have some side effect. But let's talk about what is the potential to treat this contamination, at what the other people done, and what we are offering today. To treat this contamination, you have 2 options. I call it 2 R's, either remove or reduce. Remove by the physical process. Remove by bioremediation. Okay, you can reduce the contamination. But reduce or remove, we are talking about still a fresh contamination. I mean, still you have short chain of hydrocarbon. Still you have the longer chain is not have been created yet. We are dealing with a low chain. So there is some chance for the reduction. But once you are facing a long chain or a wither, the story is different. In 1993, KISR, or Kuwait Institute for Scientific Research, and Japan Petroleum Energy Center had collaborated and had done a small pilot project for these. They have done like 3 different processes on the bioprocess, land farming, bio, and compost. Within 5 years, they found that there is a reduction, but the reduction only for the volatile and the semi-volatile. And this project, after 5 years, they concluded or they found the following. They found that when the concentration is above 20,000 milligrams per kilogram, that means above 2%, the bioremediation or the microorganism will face a big challenge to destroy the long chain of hydrocarbon. Also, when the age of oil spill increased, that means the more weathering has occurred and less biodegradation. And the reason, because the element of the carbon is the only element in the whole world who has the capability to interact and to interfere with it with himself. You know, if you leave the hydrocarbon like for 2 or 3 years, the longer chain will be created. So when you have more chain of carbon, that means a big challenge for microorganism to break it down. And when you have more hydrocarbon or longer chain of hydrocarbon, that will reduce the chance for the population of microorganism to increase. Today, we are offering a new enhancement regarding for the bioremediation. There is, we can call it as the earthworms or the thermoremediation. Actually, the thermoremediation or the earthworms has the capability to survive with high contamination, but not high like the 20,000 milligram per kilogram or 2%. They have the capability to survive. So what we have done here, we have implemented 2 experiments. We have implemented 2 experiments to see the potential of earthworms. Do they have the capability to reduce the contamination? You know, actually for the earthworms, it's considered an inexpensive technology, and furthermore, it's ex situ remediation, and also it's environmental friendly. There is no chemical use. You need only to take care for the atmosphere of the environment. Okay. For the first experiment, we use the earthworms to see if they have the capability to survive with high concentration of contamination. So 100 of earthworms have been used. Actually, 2 kinds of earthworms have been suggested in this particular experiment. One we call it Ephetida, we call it the tiger, and terrorist, which is another earthworms. Also, there is some evidence they've done some biodegradation for the hydrocarbon. We use these 2 worms. We left them for 5, 10, 20, and 30 days with different concentration. If you see the table 1 for the Ephetida, like when the concentration is 10,000, which is 1%, 2%, which is 20, 3%, which is 30,000. After 5 days for the Ephetida, they can survive. When the contamination is increased to 30,000 or 3%, we found that the Ephetida can be died because more chain will be created. So they don't have the capability to survive. And therefore, we went with another experiment after we selected the earthworm, because regarding for the first experiment, we found that the Ephetida or the tiger has the capability or has the ability to survive, you know, during the high or different contamination. That's why we had taken this Ephetida, okay, for the next experiment. Okay, the next experiment, we have taken these Ephetida or the tiger worms and left it for 150 days to see which kind of contamination can be digested. Because as we said in the beginning, today we are facing not with a fresh crude oil or like a normal hydrocarbon. We are facing the long chain of hydrocarbon. That means the microorganism not able to break it down. You need someone to break it down for them, to let the meal easy for the microorganism to digest it. So we used like 200 earthworms, 1 kilogram. We left it for 150 days. We keep the moisture around 25%. We have done 2 table or 2 study. one study with earthworms and the other without, we found that the TBH, or the total petroleum hydrocarbon, could be like 42% can be removed with earthworms, and without only 11%. And if you see, like for the volatile and the semi-volatile, most of them can be digested or can be biodegraded with the earthworms. So this point leads us that the earthworms can do some work here, or can do some acknowledgement in directly way and indirectly way. Directly way, by digest, and indirectly way by simulating the microbial activity. Because there is some bacteria in the body or in the tissue of the earthworms. So these two things, or these two factors, help the earthworm to digest this microorganism. So finally, we found that around 42% of the total petroleum hydrocarbon could be digested. That means, when you reach about 30%, you remember in the beginning we started when the contamination was 30,000 ppm. It was a big challenge for the bioremediation to be successful technology. But today, with the earthworms, it gives us like the potential to digest the contamination, even if the contamination is 30,000. So today, do you think that the thermoremediation will be available alternative to reduce or remove the TBH? The question, or the answer to this question, because when we have this contamination, the contamination is started from 10,000 or 10%, which has been 100,000 milligram per kilogram. All the oil contaminated soil, the hydrocarbon or the weather, is started from 100,000 milligram per kilogram. So you have high amount. You need to reduce it to 30,000. When you reduce it to 30,000, then you can allow the earthworms to start. But how you can reduce this one? Before 2 years ago, exactly, I came here in Bratislava with an idea. It was as a patent. It's not even registered. It's only registered. I haven't got my patent yet at that time. For 1 year ago, I got my patent. I transferred a new technology for the soil washing. It's environmental friendly technology, no any chemical. With water, we can extract all the oil. I know as a scientist, it does not make sense, because their theory like dissolve like, polar dissolve in polar, non-polar dissolve in non-polar. How come the water can extract the oil? Because we let the water act as solvent. When the water acts as solvent, it can extract. That's the patent we have. I registered my patent here in GCC. I mean GCC in my country, and in US as well. 2 MOU has been signed with 2 bigger K companies. One called KMBC and the other called KOC. And at that time, when I started, the main target to reduce the contamination from 100, because as we said, and as I think, I'm gonna say like you agree with me, we cannot like let the bacteria and give them like the contamination which is above 100,000 milligram. It's so challenging in front of them. That's why we need to reduce this contamination, to let the microorganism can digest this withered oil easily. Therefore, after we signed the MOU with KMBC, we started the pilot. The pilot, as we said, is a soil washing technology. If you see here in the beginning, let's go to the second, maybe it's more clear. Number 1, it's for sieving. Then number 2, the soil washing for 1 hour. After that, we send it to number 4, which is the sand separator system. After number 4, we send the water for treatment to reuse, and then the oil sludge or whatever we can have, we can take it out of the treatment. That's the kind of treatment. If you see these figures, that's the kind of the sample before and after. If you see, it was almost black and become normal. Even for the physical analysis, without physical analysis, by the physical vision, you can see how it's become a difference. So 2 certificate or 2 approval letter has been we have got it from the 2K companies. If you see here, we reduce the contamination from 18 to 3,000, and from 11 to 900. And for the KOC is the oil production company who have this contamination, who have 22 million meter cube of contaminated soil. We reduced the contamination from 85,000 to 9,000 within 1 hour, without any chemical, with only water. So this project is considered in my country one of the best projects as environmental type, because there is no chemical, only with water. That's why when we went with earthworms, we decided, to go with the bioremediation with no chemical, with only with ecological system. And this is the type of contamination, or the soil, sorry, before and after. And finally, for 6 months ago, this invention has got the golden invention in Geneva as one of the best technology in type of environment. Recently, as I told you, I like Bratislava because my started point was here from Bratislava. After 2 years, now I have 3 projects. I have the idea is changed from lab scale to pilot to commercial scale. We have some machine now running in Oman, and we have some machine now running in Kuwait. In Kuwait, we have a project around 64,000 meter cube of contaminated soil, and now we have this machine and we have this capability to treat this contamination. Thank you, Bratislava, and I appreciate you guys, to give us this chance to explain and to discuss about the thermal remediation. Thank you so much.
Thank you, Dr. Almutairi, for your nice presentation. With that, I will open the floor for discussion if there are any questions. Yes, Many.
Thank you for nice presentation. Can you tell us some drawbacks or limitations of this technology concerning, for example, soil structure or life cycle of earthworms?
For the earthworms or for the soil washing?
Soil structures, probably the life or mortality depends on enough carbon source, aromatic carbon source, uric acids for earthworms, and also so life cycle and soil structure, some limitations.
Actually, regarding for the life
maybe
cycle,
some drawbacks.
For the limitation, for the technology, we can treat the whole different type of the oil contaminated soil. Unless it's still a sand, there is no oil sludge, we can treat it. So the maximum we can say the limitation is 10,000 milligram per kilogram, 100,000 milligram per kilogram for the TPH or for the oil content, let's say. Okay, and regarding for the life cycle, this technology now, it's working batch by batch. That's yes, batch is not continuous. Each batch will take 1 hour to treat. And right now, we are treating around 100 ton per day. 100 ton of contaminated soil per day. Around 16 ton per hour.
What about soil structure? Maybe sandy soil or...
It's sandy soil.
Sandy soil.
Sandy soil.
No black soil is...
No, there is some black soil. This is a good question. See this figure here? Okay, if you see this figure, because some of them, we have oil lamps. So we cannot put the oil lamps inside the machine. We need all the fractions should be fine fraction.
And how often you need to supply the new earthworms? The conversion. So every 14 days, every month, every week, you supply the new. How often do you supply the new earthworms in the soil?
For the earthworms. Yeah, for the earthworms, actually you can lose 20% of the earthworms every 2 months.
2 months.
Yes, but there is a production. There is a...
Thank you for the discussion. I will, with regret, do we have more time? Okay, one more question. Let's go.
Yeah, it's really short. Thank you for your strong presentation. And I just want to know, where do you do the earthworm treatment? Do you put after soil washing, do you put the soil back to the original spot, or how does it work? Do you do it in situ or at the site?
It's a good question. Here, actually, I found a good presentation, one over there. It's mentioned that the limitation should be below 2,000 milligram per kilogram in Romania, which is the acceptable limit. But in my country, the acceptable limit is 10,000. But here, we reach around 1,000. It's below 10,000. So we can dump it in landfill, okay, so we can reuse it. That's the planning.
Okay, thank you very much for the discussion. With that, I will take myself the floor.
Yes, I will give you the floor.